Paper 2, question 9. So this is relating to the AS circles topic. We've got a circle with a given centre and a point through which, 2 points through that are on the circle, and we're asked to show that PQ is a diameter. The easiest way to do this one is to recognise that a diameter passes through the centre of the circle, so the midpoint of the diameter will be the centre of the circle. So for part A, the midpoint of -9, 8 and 15, -10. The way to find that is to add together your x coordinates and divide by 2 to find the average, add together your y coordinates and divide by 2 to find the average. So that gives you 6 divided by 2 is 3, and -2 divided by 2 is -1. So it passes through the centre, therefore it is a diameter. Part B, find an equation for the circle. So we should know that from the coordinate of the centre that the first part of the equation is x minus 3 squared add y add 1 squared. So multiply these two coordinates by -1 and substitute them in here. And that's equal to the radius squared. So we need to find the radius. We can either do that by finding the length of the diameter, so the distance between PQ, and then dividing it by 2, or we can just find the distance between the centre and one of those two coordinates. So I'm going to do that, save me an extra bit of work. So our centre is at 3, -1, and point P is at -9, 8. We use Pythagoras to find the distance between those. So the length here of the radius is 3 take away -9 squared, add -1 take 8 squared, and then square root in Pythagoras. Now that gives us 15. 12 squared add 9 squared is 15 squared, and then square root, but the equation needs to be equal to 15 squared, the radius squared. So you can either substitute in 15 squared or 225, and both of those are acceptable answers there. For part C, find the length of the shortest distance from A to the chord PR, giving your answer as a surd in its simplest form. So we need to think about what this looks like. So R also lies on the circle, so I'm going to pop R up here. The length of the chord PR is 20 units. So that length is 20. The shortest distance is the one that is perpendicular between the chord and the centre. So now I have a right angle triangle where this length here is 10 because it's half of that chord. This length here is 15 because it's a radius, and then 15 squared take away 10 squared will give me that length there, the shortest distance squared. So square root of 15 squared add take away 10 squared because we're finding a shorter side, and that is 11.2 units. For part D, we're asked to find the size of angle ARQ, so A is the centre of the circle, so ARQ, giving our answer to the nearest point 1 of a degree. So I'm going to draw in the triangle ARQ, and I want this angle here. Now it's worth noting that that angle there, ARQ, is the same as angle AQR, because triangle ARQ is isosceles because it's made from 2 radii and a chord. I can now see that I have in this triangle a right angle triangle because the angle opposite the diameter at the circumference is a right angle, and I've got 2 side lengths of that triangle. The diameter is 30 because it's double the radius, and this side length is 10. So to find this angle here, which is the same as this angle here, I have the hypotenuse and the opposite. So I can use the trigonometric function cos theta is opposite divided by hypotenuse. No, I can't. I can use the sine function. Sorry, did this differently last time. So for this angle here, the opposite is 10, the hypotenuse is 30. So inverse sine of that angle, sorry, I'm messing this right up, aren't I? Inverse sine of opposite divided by hypotenuse gives me the angle that we're looking for, which should be 48.2 degrees. It would be if I put the right values in. That should be a 20, shouldn't it? Because we need the whole of that side length there.